This problem says find the interval and the radius of convergence. So here's the series here. So we're talking about this convergence thing, so right away we should know ratio test. So that's the limit as n goes to infinity of a sub, oops, let me get my k's in there, k plus 1 over a to the k. So that means this is really the limit as k goes to infinity of pi to the k plus 1 over x to the k plus 1 over k plus 1 to the pi, and that's all divided by, and on the bottom we're going to have pi to the k, x to the k over k pi. Okay, so this now, we're going to flip all these and multiply. So the bottom's going to be flipped. So this is really the limit as n goes to infinity. And I'm going to just write this in another way. So that we can see the canceling of things very easily. And this is times, and on the top I'm going to get a k to the pi. And then this is going to be pi to the k, x to the k. And then we're going to get all these canceling. And that's it. Remember, these aren't going to cancel because the bottom one's a k plus 1 power. All right, so this is what we end up with now. So this equals the limit as k, oh, I did n again. There, I fixed it. K goes to infinity of pi, I got a pi there, and I have an x, and then a k pi on top, and then on the bottom, I'm going to have a k plus 1 to the pi. All right, so I'm going to pull that pi and that x right out. I don't need it right now, and those are just constants. So I'm really going to have k to the pi over k plus 1 to the pi. And honestly, since these are the same powers, I can honestly just write it this way here. And then from here, I can actually get into that limit, so, or get into that power. So what I mean by that is, I get this, and I have a parenthesis here, and I'm taking the limit as k goes to infinity of k over k plus 1 to the pi power. Actually, it's like a composition that I have with limits when they exist. So then, this actually equals pi x. And this limit in here is L'Hopital's rule because it goes to infinity over infinity. So then I can take this limit and say it's really the limit as k goes to infinity of 1 to the pi. And this really just equals pi x times 1, which equals pi x. Now remember, this here has to be less than 1 for this ratio test. Okay, so that tells me then that pi x is between 1 and negative 1, which implies x is between negative 1 over pi and positive 1 over pi. Now what we're going to have to do, and we ran out of room on this page, so we're going to flip to the next page. Now we're going to have to determine if these n values are included in that interval. So that's what we're going to do next. So we're going to check with negative 1 over pi first. So I got to rewrite this series on the next page. So now on this page, I just wrote down the necessary information. So what we're going to do now is plug those in. So I have this series, k equals 1 to infinity, and I get pi to the k, and then for this x, I'm plugging in negative 1 over pi to the k. And that's all over k to the pi. And again, I'm just going to clean this up algebraically here. K equals 1 to infinity. And since these are the same power up top, I can actually put them underneath each other, or together, I should say. So this is really going to be pi times negative 1 over pi to the k all over k pi, which equals, k equals 1 to infinity of negative 1 to the k over k pi. And so for this series is the series k equals 1 to infinity of, and I'm just going to write this another way because I want you guys to see something here. That this is the series we're looking at, and that means I'm going to have to use the alternating series test. So do you guys remember what that was? So this one says here that if I can show that it's decreasing and that the limit is 0, then I can say that it converges. So that's what we're going to use here. So to show that it's decreasing, I just take the derivative of it. And what I mean the derivative of is the derivative of the sequence of the sum of the series. So it's this piece right here. I'm going to take this derivative. And then there's just a power rule here. This is really and then I get, which this will always be less than 0. For all k. So that's one way to show that it's decreasing. Now the other thing we had to show was that the limit was 0. So, and we don't have to think about the negative 1 component, just the limit of the a sub k, and they define the a sub k as everything else but the negative 1 alternating. So it's this. And we know that this is just 0, so it just equals 0. So that's good enough for us. So now this means, since these two conditions hold, that for the alternating series test, that this implies by the alternating series test, the series k equals 1 to infinity of pi k negative 1 over pi to the k all over k pi converges. So this tells us then that this negative 1 over pi is included in this interval. Now we have to figure out the 1 over pi. So now I'm just going to plug that in and clean it up a little bit. And I'm not going to show you all that, but I'll just do it all. Now this one here is similar to the p series, k equals 1 to infinity of 1 over k to the pi. And I know since pi is bigger than 1, I know that that series would converge. So when I look at this, I would be okay with you guys saying that this series converges. And if I know this converges, that means this is also included. So then for our final answer for the interval of convergence, the interval of convergence would be negative 1 over pi, comma, 1 over pi, both included with brackets. And the radius of convergence, and this is honestly just a simple one if I was asked both of these. The easier one, the easier one would be the interval of convergence. But the radius of convergence would be r equals 1 over pi. Because if I went to the center of negative 1 over pi and 1 over pi, it would be 0. And then that distance from that out to the edge would be 1 over pi. So that's what my radius of convergence is. So there's our answers.